Myself, Alfimol Sebastian. I will be dealing with Class 12 Chemistry, Chapter 1, Solid State. Right from your smaller classes, you have learned that matter exists in different forms: solids, liquids, gases, and plasma. So today, in this session, we are going to learn more about solid state. So what are the general characteristics of a solid? A solid has fixed mass, definite volume, fixed shape, and fixed size. How about the arrangement of particles in the solid state? They are closely packed, which means the intermolecular distance between the particles is very small. The intermolecular force acting between these particles are very strong. These particles have a fixed position. They cannot move, so they can only vibrate about their mean position. We cannot compress a solid, which means that solids are rigid. Solids can be classified into two: crystalline solids and amorphous solids. Here you can see an image of quartz and a quartz glass. What is the difference between the two? Quartz is also SiO2, quartz glass is also SiO2. Both are silica, yet they are different, and the difference lies in their structure. In the case of quartz, we have highly ordered arrangement of particles, but in the case of glass, we cannot see that. So, the main difference between crystalline solids and amorphous solids is their structure. In the case of crystalline solids, we have highly ordered arrangement of particles, whereas in the case of amorphous solids, we can't see an orderly arrangement of particles. The second difference between the two is the melting point. What is melting point? The temperature at which a solid changes to liquid is known as melting point. In the case of crystalline solids, we can see that there is a sharp melting point, which means we can specify a temperature for that. Example, in the case of quartz, we can say that the melting point is 100 degrees Celsius. But in the case of amorphous solids, we cannot specify such a temperature. We mention a range of temperature like 100 to 200 degrees Celsius or 100 to 300 degrees Celsius. The third difference between crystalline solids and amorphous solids is the cleavage property. What happens when the solids are cut with a sharp-edged tool? What happens to the surface? That is the difference between the two. In the case of crystalline solids, we get plain and smooth surfaces, whereas in the case of amorphous solids, we get irregular surface. The fourth difference between the two is the isotropicity. What is isotropicity? If we have same value of physical properties in different direction, we can say that the solid is isotropic. In the case of amorphous solids, we can see that they have having same values along different direction, which means that they are isotropic. But in the case of crystalline solids, they have different values of physical properties like refractive index or electrical conductivity in different direction. And so they are known as anisotropic. The last difference between the crystalline solids and amorphous solids is the nature of solids. In the case of amorphous solids, we can see that they have a tendency to flow, and thus they are known as pseudo-solids, whereas the crystalline solids are true solids. So far we have seen the difference between crystalline solids and amorphous solids. In the case of crystalline solids, based on the intermolecular force acting between the particles, we can classify it into four: molecular solids, ionic solids, covalent solids, and metallic solids. First, we can see what are molecular solids. In the case of molecular solids, as the name indicates, the constituent particles are molecules. This can be further classified into three: polar molecular solids, non-polar molecular solids, and hydrogen bonded molecular solids. In the case of polar molecular solids, the constituent particles are polar molecules like HCl, SO2, etc. Here, the intermolecular force acting between these particles is dipole-dipole interaction. These solids are non-conductors of electricity. They are soft. The second category of molecular solids is the non-polar molecular solids. In the case of non-polar molecular solids, the constituent particles are atoms of noble gases like argon or neon, or non-polar molecules which are H2, Cl2, Br2, etc. Here, the force acting between the particle are weak dispersion force or London force. The third category of molecular solids are hydrogen bonded solids. In the case of hydrogen bonded molecular solids, the force of attraction between the particle is hydrogen bonding. What is hydrogen bonding? The interaction between hydrogen atom and electronegative atoms like oxygen, nitrogen or fluorine. An example of hydrogen bonded molecular solid is ice, which is solid H2O. The second category of crystalline solids is the ionic solids. In the case of ionic solids, the constituent particles are ions. It can be cation or anion. Cations are positively charged ion, whereas anions are negatively charged ion. In the solid state, they are non-conductors of electricity. But in the molten or aqueous state, they are conductors. The third category of crystalline solids is the metallic solids. In the case of metallic solids, a positive charge is surrounded by a sea of electrons, and these electrons are mobile, and this mobility of these electrons owes to the electrical conductivity of metallic solids. We have already learned about the properties of metals, and usually the metallic solids also show these properties, which are malleability, ductility, lustrosity, conductivity of heat and electricity, etc. The fourth category of crystalline solids are covalent solids. In the case of covalent solids, the intermolecular force acting between the particle is a covalent bond. Here, the constituent particles are atoms of nonmetals. Usually, they are non-conductors of electricity with an exception of graphite. Graphite, which is a covalently bonded molecule, conducts electricity. It is due to the structural difference of graphite. So, we have learned that crystalline solids can be classified into molecular solids, ionic solids, covalent solids, and metallic solids.